So, on today's episode, we dive into a new subject matter. We talk about fusion splicing.
Don't hang up that phone. We've found what you're looking for. Welcome to the Let's Talk Cabling podcast with Chuck Bowser, RCDD. What exactly does RCDD stand for? Registered Communications Distribution Designer. Just the expert you need to ensure your cable plant performs exactly as designed. Now, send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications.
Welcome to the show where we tackle the tough questions submitted by installers, estimators, project managers, IT personnel, anybody in the ICT industry who's looking to become a little bit better. We are connecting at the human level so that we can connect the world. If you're watching this show on YouTube, would you mind hitting the subscribe button or the bell button to be notified when new content's being published? If you're listening to us on one of the podcast platforms, would you mind leaving us a 5-star rating? Those two little simple steps helps us beat the algorithm to get this information out to more people so we can educate, encourage, and enrich the lives of more people in the industry. Thursday nights, 6 p.m. Eastern Standard Time. You get to ask your favorite RCDD questions. That would be me. It's broadcast live on LinkedIn, YouTube, Facebook, and TikTok soon, because I just breached 1,000 subscribers on TikTok. So we can do live there as well. But I can hear you. But Chuck, I'm driving home at Thursday night at 6 p.m. I can't be driving because the company don't allow me to use the company radio because I might get in trouble. They're recorded. You can watch them at your convenience. You can also go to our webpage, letstalkcabling.com, and go back and watch any of the audio podcasts, video podcasts, or any of the content that we produce. So let's get on with the show. Fiber is always one of those skill sets that I receive the most questions about. There's a feeling of unknownness. There's a Chuckism for you. I don't even think that's a word. Unknownness of fiber. People they don't know what they're doing. They're afraid to learn. People are afraid to teach people how to do fiber. But yet it can be pretty easy. Don't get me wrong, it can be challenging, but it can be pretty easy. So you have options when it comes to terminating or splicing cables. Now there's many different kinds, but one of them, and I think is the best, is fusion splicing. So today we're bringing on a couple experts from a company that manufactures a fusion splicing piece of equipment. So we can talk about fusion splicing and get some good questions for you guys. So we got Brad Everett and Pete Deloyer from American Missile Tech. Actually, you guys just changed your names too, didn't you?
We did. UCL Swift Americas.
There you go. I should have caught that when you logged in. Welcome to the show, gentlemen. How are you guys doing today?
Great, thank you. How are you?
Doing fantastic. So, Brad, why don't you give us the 30-second highlight of you and who you are and why people should listen to you?
Okay, I have no idea why they should listen to me, but I will tell you who I am. Brad Everett, I'm General Manager of UCL Swift Americas. I've been here since 2014, and we've had a pretty good run in that time here at the company. Had a lot of growth. I personally have been in the industry since '93 and have picked up a lot. Started out a copper guy and came over to the light like most of these fiber folks. Thanks for having us.
My pleasure. Pete, why don't you give us the 30-second story about you?
Absolutely. My name is Pete Deloyer. I am the Vice President of Enterprise and Specialty Market Sales here in North America. I have actually been with the company myself since 2014 as well. And I've got 30 years, a little over 30 years of experience in the industry from every facet of the business. I've been in contracting, distribution, and manufacturing. So I've had an opportunity to work with the product on several different levels.
So you guys have lots of experience. I get this quite often because a lot of people will watch the show and it might be the first time and they're like, why should I listen to that guy? Matter of fact, I was got in a conversation with somebody just the other day on TikTok, and they're like, well, yeah, there's a T568A, a T568B, and a C and a D. And I'm like, no. There's a T568A and a T568B. There is no C. And then he's like, we got in this long drawn out conversation because he didn't know the person he was talking to had 40 years of experience, right? And sat on his committees. But that's why I go through those introductions. So that way the audience has a better feel for who we're talking to and why you bring value to this conversation and why they should listen to you. Now, Brad's been on the show before, so he's a repeat offender. I mean, a repeat guest. So, so anybody who's been listening to the show for a while probably will recognize him. So there are different ways to terminate fiber. And I mentioned this in the intro. I learned old school, right? We had this big machine that was probably 24 inches wide, 24 inches across, had these two big discs on it, and you had to put your connector on there, and it had to spin for 15 minutes, and you had to put on the other one, spin for 7 minutes, and then spin the other one for 7 minutes, and then it took 15 minutes literally to put a connector on. And then they went to the two-part epoxy, then they went to the mechanical. And now, and I don't say this is not a recent thing, but I think because of innovation of technology, fusion splicing is becoming an alternative, a cost alternative as well, right? So can you for those who may be listening and may not know, what is fusion splicing? Can you give us what is that? What exactly does that mean when you're fusion splicing fiber?
Okay. Well, fusion splicing is basically arc welding glass. You're going to align the two pieces of fiber. You're going to strip it all the way down to the 125 micron. You'll strip it all the way down, and then you're going to align those two fibers using some reference, either the clad or the core. And then through an arc, you're basically going to weld that glass together in a way that's very precise. And actually, the performance that you can get out of a splice could literally be so good that it's like having new glass. Something that an OTDR or any type of test equipment may not even pick up in testing the trace.
A fiber strain has core and cladding, right? So you say it melts the glass or melds the glass. How does it maintain that core all the way through, or does it not do that?
Oh, it does. It absolutely does. Yeah, it's the arc. The arc itself it will hold the construction of the glass. So it's not like it melts it. It literally welds it together, and you're able to maintain the consistency and the construction of that core and clad right through the whole splice.
So make sure I understand this correctly. I know a little bit about welding. I'm not an expert on welding, but when you weld two pieces of metal together, right? If it's a really thick piece of a metal, you're really only welding the top portion of it, but it's making those two pieces of metal one, right? So if I understand you correctly, when this welds the glass, it's not really welding the core together, it's welding the outside of the cladding together, so it holds them together. Am I understanding that correctly?
So again, when you're talking about fusion through IPOS technology, so it's image pattern alignment analysis system, what it's doing is it's aligning the concentricity of the cores together, okay, and then through an 1800 volt arc of power is physically melting the glass on each side and making it one unit again with the alignment of the fiber intact.
Gotcha.
So essentially that it's, when you say welding metal versus welding glass, two completely different types of welds, obviously. But with the glass, it is fully adhered all the way through the physical face of the glass.
Yeah, I wasn't trying to imply that you were breaking out a TIG welder and putting the glass together. I was just trying to use an analogy. Yeah, I know better than that. Hey, I got my TIG welder out in the shed, and I got some single mode fiber. We'll make that work.
We're gonna make it work.
Yeah.
We'll get it.
Yeah, my dad always used to say, if it doesn't work, you need a bigger tool.
That's great.
Yeah.
And if you don't need a bigger tool, you definitely need more tools.
Exactly. That's why I love my wife's honey-do list. When she gives me some new project she wants to build, I always tell her, hey, to do that project, I need this new tool.
Mm-hmm.
That's how that works. Exactly right. So it sounds pretty complicated. What's the learning curve for somebody who wants to learn fusion splicing? Can somebody right coming straight over from copper learn how to fusion splice, or is there a long learning curve to this, or what?
For the physical application itself, it really depends on what type of fusion splicing you're doing. As I was coming up through the industry, it was absolutely a trade that you worked toward becoming an actual fusion splicer. With today's technology, ours in particular, we have the ability to get a novice green employee pretty much splicing within the hour. Okay. Now, again, that application needs supervision. Okay. When you're talking about a brand new guy, if there is no experienced technician on site, okay, you're opening yourself up for a lot of problems. Okay. But there are different types of splicing. There's manual, and the manual stripping of fiber optics. That really becomes the challenge of learning how to proficiently be able to splice or strip a piece of fiber. That learning curve is going to have a much larger time than ours. Ours, you just put your fiber optics in a holder and you move it from station to station, and the actual splicer itself will strip the fiber. So again, it really depends on what type of product you're using and what level of experience you're dealing with as to what a learning curve is going to be for you.
Well, you've got two aspects of that too, Chuck. You got one aspect is the use of the machine. And that's the piece that can be taught in a classroom environment. I mean, you can learn to use the machine itself as it is splice. Where the trickier part becomes, and where it becomes so much more broad, is in that field application. Being able to use a splicer is not going to help you open up a coyote enclosure. How to, routing fibers through splice trays and that kind of stuff. It's the other side of splicing is really that field application, and that's what really requires a lot of expertise.
There's many facets to it, just like you said. There's the learning. The hard part is always what you learn in a school setting or a training session, and then when you actually are sitting in a closet with that dim temporary power, and you're trying to remember all them steps. There's a learning curve there, but it sounds to me like it's a lot easier than it used to be. Is that a correct assessment?
100%
Yeah.
question.
The equipment needed. Well, before we're talking about equipment, let's talk about the applications, right? So it used to be fusion splicing was only used for emergency restoration or maybe, putting backbone cables together. But now people are buying, pigtails to fusion splice behind the telecom enclosures and stuff. What do you think is the most common application for fusion splicing that you've seen from your side?
What we see more than anything today is end-of-line termination. So as you mentioned many years ago, it was a puff and polish, a two-part epoxy, what have you application, whereas today the end-of-line termination is primarily the choice termination to be used. So, and whether that be a pigtail, splice-on connector, what have you, that's where you're seeing the physical splicing take place. Again, you still have mid-span application, and that's going to play into effect as well. But you're seeing more splicing across the full channel of fiber, whereas it was just mid-span application at one point.
Right.
What are you always analysis of that traditional use for fusion splicers? There was always that traditional use that was mostly out on the poles, guys in bucket trucks out on the side of the road. That was the traditional splicer market. And now we're really seeing this growth, this whole new segment of splicing technology being used, where the splicer is used as a connector termination tool or some type of a termination tool in the last mile. And that really is where we've seen the growth in fusion splicing, at least over the last 3 to 5 years.
there's been a big movement in our industry driving it further and further out, closer towards the customer. And there's a lot of companies out there. Companies can be broken down in a couple different categories, right? You got the big companies like the Hinkles and McCoys and the big ones that are all over the United States. And then on the opposite side of that, you've got the people who were, I've been pulling cable for 20 years, not 20 years, 10 years, and I'm starting my own company. So they're small companies, me and one other person. Even the small people, the small companies are getting into fusion splicing now because it's so much easier, and it opens up many more doors for them because they may not know how to do a hot melt termination or a two-part epoxy. And you can get the same, because you can buy a pre-terminated factory assembly and then fusion splice it. And what's your typical fusion splice loss? 0.01?
0.02 is and the plus or minus, but 0.02.
Yeah. And that's just amazing. I mean, especially when you start looking at the fiber optic loss budgets we're allowed to have. I mean, there's talking, if I remember right, I think in the TMM, I think it calls for 0.3 dB loss, which is, if you're getting 0.3 dB loss, dude, McDonald's is hiring.
Yeah.
And I'm going to show you just how easy it is to fusion splice. I'll tell you a quick little story. So me and the other trainer, the guy that I travel with quite often, he comes straight from the AV world. He installed HDMI signal extension products, stuff like that. Didn't have a whole bunch of copper or fiber experience. So we went to a Bixie show together. And here he is teaching people about fusion splicing and stuff, and never done himself. So we went down to the exhibit hall, and I found the company that sold fusion splicers. And I said, do me a favor, teach my partner how to fusion splice. And literally within 5 minutes, they had him fusion splicing at 0.02. Never touched fiber in his life. Never touched fiber in his life. So it opens up a lot more doors. So what kind of special equipment is there? One fusion splicer for everybody, or is there different fusion splicers for different fusion splicing tools for different jobs? What is equipment needed?
So this is going to be different applications. There are 3 types of technology that are mainstream in our industry, and that's ribbon fiber. Okay, that's a fixed application. So what that is it faces the fiber and then does an arc weld or arc splice on the physical fiber. Then you've got what's called active clad and core splicing. These are active clad. This is more last mile application. Okay, and what the active clad is it's a 4-motor application that actually does some alignment on the outer cladding. So on the 125, it does some alignment on it. And then when you get to your core, that's a 6-motor application. That's more of your mid-span long haul application. Also plays in the last mile as well. And that is dialing in on the physical core itself and aligning it. Now, what you're going to find is today with the tier 1 manufacturing, the concentricity of the fiber is so close that even on a KF4A, your splice is going to be so precise that for most applications, at that last mile, this is perfectly suitable for the physical splice at hand.
Right. I'm asking for a specific number, but what's a typical investment a company needs to make to jump into the fusion splicing arena?
That's a great question. And I think that for those of us that have been in it for a while, we can recall when the numbers were in the tens of 20s of thousands of dollars for these units. And again, with the advancement of technology and the cost reduction, as you had mentioned, that's why it has become so affordable. For this one here, you're looking at about a cost investment of about $5,000. Now, to be honest, if you're heavy in termination, we have ways to get you into this unit for nothing. Cost of adoption has really become very suitable for every level of company to participate in fusion splicing.
I think that's great because, like I said, there's a lot of people I guess because it's because of COVID, I guess, but they're starting to think outside the box and looking for additional revenue streams, and maybe that might mean starting a company because there's a lot of people. I get a lot of questions about starting company, but business related questions and fusion splicing. That's why I reached out to you guys and wanted to have this conversation with you because it's something that I hear quite often. Now, I'm assuming that you guys have some kind of a training program. If I let's play devil's advocate. I just bought one. Okay, I just shelled out the money and I'm all super excited, but I'm an old copper guy. I mean, I've terminated a couple fiber jobs here and there. Nothing. I wouldn't call myself a fiber princess, but yeah, see the smile. You know what I mean by fiber princess. I saw the smile, right? Do you guys have any kind of like a formal training program to get somebody up to speed? And if so, how long is that training?
So, and that's a great question. It's a twofold answer, though, okay? Again, brand new to the industry, I would suggest that you seek out some type of physical fiber 101 type of training to understand fiber itself. We are fully versed on how to train anybody that purchases our unit on the usage of our product, but we are not going to be their fiber resource. And I think that's the hardest part. But when you do buy one of our units, we have representation throughout the country. So depending on where you're located, we will have somebody come out and physically train you or your team on how to do that. And then once you're fully trained on the unit, you can offer an extended warranty on the product when installed.
Nice, nice. What are the biggest challenges that you see in delivering fusion splicers to companies?
What do you mean, Chuck?
So every company has different strengths and weaknesses, right? So I know as an instructor, after a while, after I teach, I don't know, 20 classes, 30 classes, 50 classes, you start seeing patterns. People are kind of weak in certain areas and stuff. Like, for example, I find that when it comes to technicians with less than 10 years experience, they don't really, they get into a production mindset. They don't really think about cost impacts, right? If the customer asks me to do this one little thing, well, it's only one little thing, but there's a significant cost impact on the backside of that a lead technician or project foreman would have. So that's something that I see quite often as technicians in the field. So since you guys are selling and delivering and training a lot of people doing fusion splicing, I got to imagine that you get a lot of the same questions pop up in your class.
The thing that I see the most is in care for the splicer after you buy it. After you buy it, you learn how to use it, you take it to the field. 6 months later, you start having a problem with the unit and you call up tech support, you're screaming because your splicer's not aligning as good anymore. And then we ask if you cleaned it and you don't get much of a response. So it's the clean, it's the calibration, it's the care for the unit after the fact. That tends to be the biggest weakness out there. And I think that's probably exacerbated a bit by the people we're talking about getting into the splicer business. They see, what it is a new revenue stream. I can get into this business for this amount of money. I put this investment, I put this training, and I can be in that business. But it's that ongoing care for the unit and how to maintain that over a long period of time. Those are the things that really separate the newbies in the industry versus the seasoned techs.
Right. So for example, like a copper tester, certification tester, not a bird tester, but a certification tester. You've got to get those things calibrated every 12 months by the manufacturer in order to, so they can still guarantee that it's performing per the standards and stuff. Is there a component like that with a fusion splicer? Is there a certification thing that you got to get done every period of time, or what's that?
It's field calibrate. So you can send it back for a reset, and we can do all the things that like a tester would do, like in your case. But for the most part, these things are going to be more about cleaning, make sure it's clean. Because you're going to have residue that starts to build up over time. So how do you keep the electrodes clean? How do you keep the stage, the V grooves, and those kinds of things clean? But then on the calibration, it's actually a field calibration Because I mean, these units are actually going to sense atmosphere or sense their environment and make adjustments there in the field. So that's one of the things you hear a seasoned technician say is bring the splicer. If you left it in the truck all night, bring it inside, bring it where you're going to use it. Just sit it there, go have breakfast, come back, or go have a cup of coffee and come back. So you let it acclimate, and then you go through your calibration process. Those are the little things that again, it's the care, that ongoing thing that a seasoned guy's gonna know.
You must have been reading my mind, because my next question was going to be, what about that guy in Detroit, Michigan in February coming in Monday morning to Fusion Splice? He's been sitting in his truck all weekend. Can you just go out and start Fusion Splicing? You must have been reading my mind. You must have been reading my mind.
Hold on.
There you go. So you said some maintenance
I'm sorry, it's a piece of precision equipment. So again, if it's not treated with the utmost respect and care, okay, it's not going to perform to the best of its ability. And I think that the experienced splicer is fully aware of the importance of that cleanliness. And one of the things in my training is I will have all of the guys come through and look at what the bead grooves look like. And if they're dirty, ask them, are they dirty, are they clean? You cannot see the dirt typically that is actually sitting on your bead. And if you can't see it, then it must not be dirty. That's not the case, right? So again, as Brad mentioned, cleanliness is next to godliness when it comes to splicing.
Oh, absolutely. And that's the difference between a great technician and a mediocre technician, right? Because there's a lot of guys out there that they don't think about, that $5,000 splicer or that, $15,000 certification test set, and they just leave the truck over the weekend, not realizing A, that's a liability, B, it goes through cycles. It heats up, it cools down, especially in an uninsulated work truck. And you're right. I think that the good technicians will do that. They'll bring it in the house. Now, walk me through the cleaning process. So, what do they have to do when they actually clean it?
So, with our splicer, there's several different stations that need to be cleaned. There's your automatic thermal stripper, okay, and depending on what type of material you're using, is on how you're going to clean it. If you're using 250, it does not come off as one tubular piece. It actually comes off in shards or basically shreds of the acolyte coating. If you're doing 900, it actually comes off in a complete tube. So again, what you're really trying to do is make sure your blade point that's actually holding that material is kept clean, because again, there's a gap tolerance at your blade. And if you have any kind of debris on that, it's going to change your gap tolerance and therefore could damage your fiber. When it comes to your cleaver, you just want to make sure all your pads are clean and free of debris. Again, when we're talking about aligning a single mode fiber, okay, we say the 125 is about the size of a follicle hair. Then we try to break that down to the individual and let them know that you're talking about a core inside of that the actual information is traveling on. When we're trying to align that, again, if you have a piece of glass that's still left on one of the pads and then you lay a new piece of glass on that, you've altered the angle in which that glass is now receiving the blade, okay? And that can change, that can cause you several problems at the point of termination. When it comes to physically cleaning the actual unit itself, V-groove, the actual channel itself is the most important application in the whole process. Okay, that's where your glass is going to be held together, held in the channel and brought together. All your alignment happens right there at your V-groove. So again, cleaning that, we state you should have your cleaning brush. It should be its own brush, not used for any other application in the actual cleaning process on the unit, just cleaning the V-groove. And every 10 splices, you should just give it a quick brush. Just make sure you got everything out. What can happen is a lack of cleaning over time. Your V-grooves are ceramic, okay? You've got essentially what it is ash coming off of whatever leftover acrylite might still be on your glass, greases, oils, what have you, okay? That ash can actually in time get physically baked onto the actual V-groove ceramic itself. Once that's baked on, it becomes a solid again and will permanently alter the angle in which your fiber's coming in to the final mating process. So again, those are your primary cleaning applications when it comes to this. There's also mirrors on every Fusion splicer. There's going to our camera lenses, and your camera lenses need to be also cleaned in time. If you have particles and debris that fall on the camera cannot delineate between your fiber optic glass and a piece of aramid yarn or what have you, whatever drops down on it.
In front of line the trash.
And do you teach that cleaning process in your training class?
100%.
It sounds to me like there's two levels of cleaning, right? The cleaning as you're going ongoing, as you mentioned, yeah, every 10 Fusion splices or whatever. But then at some point, there's got to be like an overall general cleaning too, right?
So, and this is kind of what Brad had mentioned, and it's what I've been here again going on my 8th year, and I think I'm most surprised about this. Every unit comes with a 3-year warranty, and we give you 3 annual bumper-to-bumper cleanings. So essentially what they will do is they will come in and do a full clean on the unit. And I think maybe 6 times in 8 years, we've seen people utilize that. It's one of the most misused offers that we have. And I think that's just through time. These get so busy when they're not being in use. The companies just forget about that offer and they go into the shelf and they go into a routine. And that routine, it's hard to break from that routine and say, reminder, I should send this in to get it clean. So.
Oh, 100%. We come across that all the time. For example, the yearly certification. One of the testers, I won't mention who the name is, but one of the testers, when you get close to that 12-month period, I think it's within 30 days, when you turn it on, a screen pops up and says, hey, in 30 days, I need to be calibrated. Hey, in 29 days, I need to be calibrated. And they still don't get sent in because the technician just bypassed through and doesn't think about it. It happens, unfortunately. But so you mentioned the 3-year warranty. That's actually pretty cool. And it's cool that you do the cleaning process too, because I got to imagine that you guys would be way more thorough than somebody out in the field, right?
Yes.
If somebody were to invest in a Fusion splicing tool, what kind of return on their investment could expect? What kind of a life cycle? Is it a number of splices kind of a number, or is it a time kind of a number?
I don't know. Been here for 8 years. When I see it start to, I think what happens is the technology as it advances, like a car. Okay, you want the new bells and whistles before the car's actually dead. We have units that I sold into the system in 2014 that are still going very strong. Our electrodes are good to 36,000 burns. Okay, our cleaver blade is good to 74,000 burns or cleaves. I have never seen that many splices, and most of you listeners out there, I'm sure some of you have that many splices. I just have not been seeing it yet.
I was just going to say, my brother works in communications too, and he's a field supervisor, and he just finished doing a large data center for one of those big companies that ships overnight and offers free TV services, if you know who I'm talking about, because I can't say who it is. And he did one of their data centers, and he was pulling 6,000 strand fiber cables. And so I could see somebody getting up to that number pretty quickly. So it sounds like you get a pretty good long life. It sounds like like you said, you're going to be more apt to you want the newer model because it's slicker and it's got more options before yours is even worn out.
And the physical care is really, again, what we see is repeat customers are due to lack of care. Technician dropped it off the top of a ladder. Stolen, theft. Theft is a big thing. So it's not due to the fact that the physical splicer itself is at the end of its life cycle. It was either helped to the end of its life cycle or again theft.
Do you find that companies, when they want to buy the new latest greatest Fusion Splicer, those that don't get stolen, those don't get dropped off the top of a ladder, because we know those never really happen, right? Those are big fallacies in the industry. Are they keeping their old Fusion Splicers, or are they trading them in for or like in a trade up program? What do they do with their old Fusion Splicers?
So we don't have a trade up program per se. I think what you'll see is they go into third market sale, and you see a lot of that there. Key to third market sale is buyer beware. Okay, especially for us, if the unit's stolen, we receive it back as a repair. We are obligated. We have police reports on the units, and we are obligated to report that. You're not going to get that back. And these are things that you really cannot decipher when you're paying for it on eBay or some other third-party marketplace. So again, what you get when you buy from us is you get that support, you get that long-term relationship, and you get every salesperson that's within our country. You've got them on speed dial essentially to help you in your situation.
So you guys have a unique view of the fiber industry, and also more specifically, obviously, fusion splicing. What future trends or what new technology do you see coming down the pike that's going to be affecting us soon?
I think we're in it. I think we're in it now. It's the technology. I mean, you're seeing things like Bluetooth technology being integrated between the splicer and the cleaver. You're seeing Wi-Fi access, and I mean, you're seeing more what I would call user level benefits. You're seeing more of that than you really are a change in the splice function. I mean, the splice function it's been pretty stable over the last couple of years across all competitors. And what you're really seeing more of now is that individuality. Like in our case, you're going to see much more of a user friendliness. How do we make that same splice process that every manufacturer is doing? How do we take that and make it more user friendly? How do we make it so that it's easier to train and more easily deployed and used in more applications? I think that's what we're seeing at this point. I don't see anything that's going to make this get better. It's and again, there will be improvements as there are in everything, but I really think we're starting to see the front end of that big wave. That's going to be the use of fusion splicing toward more applications. Again, like we were saying earlier, I mean, everything from the desktop to the data center to fiber to the home, and I mean, all of those things, all those places where there is fiber connectivity, we're in the infancy of big market growth in that. And I think it's a wave that I don't think it's just going to be a trend. I think it's going to take over the way we terminate fiber.
Gotcha. So let me ask you this question: when you're terminating, you're doing your fusion splicing, right? Does it generate any kind of documentation that the technician needs to save or upload, or that a customer might want to see?
So there is a documentation that's offered, but in all reality, it's not going to take place of your standard channel test that is going to be required. What the physical data is going to provide you is what your cleave angles were, what the temperature was, date, time, type of fiber. So it's not going to be any test data that they're going to be able to use to certify the actual splice itself. Right. It's just going to give you the parameters of what that splice was. And there are customers out there that do want to see that data. And in the event that they do, yes, they have the ability. This unit here will hold up to 5,000 physical splice data. And the unfortunate part is you cannot manipulate the data inside the actual splicer. You can't manipulate it until you upload it into an Excel document. And so it's critical that if you are going to utilize that information, that you're keeping copious notes as to what splice correlates to what physical splice you've got.
Gotcha. Yeah, I wasn't really talking about certification testing, but I know that I have had customers in the past that wanted to know the actual splice settings when you're doing that kind of stuff. And I've come across that in the past. It's been a while, but and I figured there's probably still customers out there doing that.
Yeah.
Yeah, you can even capture a screenshot off of the splicer, so you can see the splice itself.
There you go. You should make an app so somebody can connect to it with their smartphone and then download it and then email that to the customer. I'll give you that one for free. You can use that one.
All right, take it.
It seems like there's an app for everything nowadays. I mean, everything. So what else do you guys have that you might want to touch base on before?
I don't think so. I mean, I don't know of anything that I would add to the conversation. We have definitely seen that growth in fusion splicing, and which is definitely justifying a specific podcast on the subject. It's the deployment of fusion splicing is definitely on the rise, and like we've said, the different applications for it just keep growing.
My vision, I'm putting myself out here. My 5-year vision, maybe 10-year vision. Heck, I might even be retired by then. I don't know, because I'm getting kind of old. I really foresee that discrete terminations will only be done at a factory. They'll ship you the things, and everything will be fusion splicing, because it's going to be so much more resilient, so much more better connection, and so much easier to do that at some point, everything's between you, me, and the shade tree. Every time I teach a class, when I'm teaching the fiber section, I always ask them, what kind of fiber termination do you do the most? And the number one answer is fusion splicing. The number one
answer. Again, it's not for the experience. It's not just for the experienced technician. I'd like to add that we are throughout the U.S. and Canada, and if you would like to see a demonstration of our product, I believe there's going to be a clip that you can see. We have videos online, as well as physical sales reps, again, throughout the country. If you'd like to see a video, please give us a call and schedule it down.
Very cool. And then I'll put your website address and stuff in the description too, so that way they can go there and see those directly as well. Because I get a lot of that as well. People always ask me, "Where's the follow up on that, Chuck?" Because I can't put everything in a 30-minute podcast. Just
Yeah, true. One other thing I'll throw in there, Chuck, just for the audience here is the need for people to splice. I mean, every segment, every restaurant, every retail, every industry right now has some type of a need for labor and workers. I can tell you one of the biggest things I hear across the industry is we need people. So if somebody's looking at this as a possible career path, and this is, if you're right out of high school, this doesn't require a degree. It requires somebody who wants to get into it, wants to understand the technology. And I can tell you there are jobs, and I mean good careers, to be started right now in the fusion splicer industry.
Yeah, I agree 100%. So I got one question to ask you. Who's better at terminating fiber, men or women?
Women,
Without a doubt.
without a doubt.
Without question, it's women.
Yeah.
The attention to detail is far greater than men.
And I found as well, because I used to be a Bixie trainer when I used to work for a big company, and I trained lots of people, men and women, and there's a fiber termination net. I found that men come to a class with a preconceived notion. Oh, I already know this, and they don't take instruction very well. Women are great learners. They love absorbing information, and their motor skills, their fine motor skills are more developed than men. They're men. We tend to be a bull in a china shop, right? And women are more finesse. So that's I've never asked anybody else that question before, and it just kind of came up in my mind as we were talking. I was like, oh, I got to ask this one because that I just been a perception that I've had. So
Absolutely.
Yeah.
Dexterity, organizational skills, and in those trays, and that eye for detail. I mean, again, a lot of these experienced splicers have it, and of course they've been doing it for years. So those guys are tried and true. But when you're talking about new people getting into it, I definitely think there's a female advantage.
Yeah, and I love the fact that you called it a career path. Right, this is not a job. There are a lot of people out there that are fusion splicers, fiber optic techs that are making a really good living. Really good living.
Yeah.
Absolutely.
Gentlemen, I appreciate you coming on the show, and maybe we'll have to have you back.
That's good. Thank you for having us, Chuck. It really was a pleasure.
And we'll see you at Dixie.
Yeah, I'll definitely be over there at least for the exhibit halls. I'm not sure if I'll be there for the actual conference yet. I'm still trying to work out those details. I mean, it's only an hour from my house, but I got to figure out my training schedule next year first before I worry about going to Bixie. So
I'm sure we'll see.
Yep. All right, gentlemen, it's been a pleasure.
Been a pleasure. Thank you much.
Take care.
Until next time, everybody, knowledge is power.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.